Thanks for coming to the session, and thanks for having this paper in the program. It's joint work with Benny Kleiman and Stephen Redding. It's a paper about dynamic spatial equilibrium. So what is the motivation? Well, a key question in spatial economics is how does the spatial distribution of economic activities respond to local shocks? By shocks, we mean changes in location-specific productivity or amenity, or location pair-specific frictions in migration and trade. Now, the response of economic activity to changes in these fundamentals can be gradual due to either migration frictions for factors that are mobile. For example, it takes people several years to migrate out of declining states into rising states, or due to slow accumulation and depreciation of immobile factors, such as local land, buildings, and structures. So a key challenge in the literature is how to incorporate in a tractable way forward-looking capital investment decisions into spatial models with population mobility. Why is that challenging? Well, the investment decision and migration choices in each location, they interact with one another. And in particular, these choices in each location also depends on the equilibrium choices in all other locations and all other feature periods. So if I'm contemplating moving into Texas, Austin, I would like to know what is the trajectory of capital stock and population in Texas, Austin relative to all other locations that I could migrate to. So you can see it's a complex problem where the dimensionality could quickly go out of hand. So we make four main contributions. First, we develop a very tractable dynamic spatial model that has both forward-looking investment and forward-looking migration decisions. It's tractable in the sense that just like workhorse models in static trade or static spatial models, where these models are amenable to many extensions, same property applies in our setting. In the paper, we're going to set up this model that is in its simplest form, a single sector model per location. But we're going to show that the model generates a large number of extensions, multi-industry, input-output linkages, and so on. We're going to characterize and analyze the model. We're going to show existence and uniqueness of steady state. We're going to generalize the dynamic head algebra results developed by Calendo, Dworkin, Perro for dynamic migration models to include capital investments. We're going to linearize the model and analytically characterize the determinants of the speed of convergence of this economy. How fast or slow does the spatial distribution of population and capital stock converge to the steady state? What are the determinants of the speed of convergence through using spectral analysis tools? And finally, it's an application. We're going to take the model to study the income convergence across US states over time and highlight this interaction, very powerful interaction between capital and labor dynamics. So given the interest of time, I will not show you the model, but I will give you a high-level verbal summary of the model and a summary of what we can do in each of these bullet points. So it's going to be a model with many locations, and these locations are linked through a rich geography represented by a whole matrix or bilateral trade and migration cost, and the model features migration and capital accumulation. In each location, we're going to have two types of agents. We're going to have hand-to-mouth workers who are hand-to-mouth in terms of their consumption. However, they make forward-looking migration decisions, similar to the model of Calendo, Dworkin, Perro, the dynamic spatial model. And in each location, we're also going to have immobile landlords in each location choosing how much to invest in terms of local capital, land and building and structures. It is this separation of the two dynamic decisions, migration and investment, into the hands of two separate agents that generates tractability. So we're going to have a single sector model to show how it works, but the model has a large number of extensions, including allowing the landlords in each location to invest in other locations as well. So we're going to analytically provide conditions for the existence and uniqueness of steady state, generalize the dynamic head algebra so that we can compute counterfactuals without information on the unknown fundamentals. So if we want to figure out, looking at the observed trade and migration across US states, and we want to ask, well, what if New York productivity improves by 10%? What if Texas, Austin productivity declined by 10%? How would that change the migration and capital accumulation patterns? We can compute those based on observe trade and migration as sufficient statistics without knowing the fundamentals of the economy, without knowing the levels of productivity or trade frictions and so on. To go a bit deeper into the analysis, we linearize the model to have a closed form solution for the entire transition path that analyze this, that characterize the spatial distribution activities. But we're going to use that linearization to gain insights about the convergence property or the speed of adjustment of the economy to various types of shocks. What I mean is the following. We can stack all endogenous state variables in the economy into a vector. So X, think of it as a whole vector of population across US states and a whole vector of capital stock across US states. We're going to have a matrix P that is constructed using observed trade flows and observed migration flow, as well as a few model parameters, form sufficient statistic for a matrix P that governs the updating of these state variables, which captures the period-to-period changes in the state variable. So the properties of the matrix P governs the convergence property. How quickly does the economy go to the steady state? And by looking at the eigenvector and eigenvalues of the matrix P, and by analyzing the content of those eigenvectors, we can understand a lot about convergence. So eigenvalue themselves capture the rate of convergence. A high eigenvalue means the corresponding eigenvector, if the eigenvector coincides with the state variables, that state variable will converge to steady state very slowly. Low eigenvalue captures quick convergence. And the content of the eigenvector itself, each coordinate corresponds to a population or capital stock in various locations. The loading on population and capital stock and their correlations across states tell us economics about when does the economy adjust quickly or slowly towards aftershocks. So we're going to show that economy's transitional dynamics is shaped by an interaction between migration and investment dynamics. In particular, the adjustment of the economy towards steady state is slow if the gap between capital and steady state level and labor and steady state level, if those capital and labor gaps are positively correlated across locations, then the convergence will be slow. Conversely, if the capital and labor gap relative to steady states are negatively correlated across locations, convergence will be fast. Why is that? Well, that's due to capital labor complementarity in production. So consider, a configuration where half of the US location has high capital stock and high population relative to steady state, and the other half have low capital stock and low population. High population implies return to capital will be high in half the states, so the depreciation or the deaccumulation of capital will be slow. High capital stock will imply wages will be high in those states, which retards the outmigration of population. So that will be a configuration that corresponds to a high eigenvalue in the system. So by looking at the entire spectrum of eigenvalues, we can understand a lot about how quickly does the economy respond to shocks. And by looking at how the spectrum of eigenvalue changes in response to underlying parameters, for example, discount rate, depreciation rate, or the taste for variety in terms of consumption goods, how the spectrum of eigenvalue change in response to those parameters will tell us about how those parameters affect the speed of adjustment of the economy. So in terms of application, we compile about half a century of US cross-state migration and trade data, as well as 16 years worth of data at the state by industry level, capturing migration and trade flows. We used the model to analyze the decline in the observed empirical decline in the rate of income convergence over time. And we analyzed the convergence and properties and heterogeneous incidence of shocks to local economic fundamentals to highlight this interaction between capital and labor dynamics. So to summarize, we think the main contribution in the paper is to provide a very tractable framework that can be used quantitatively and amenable for many extensions to analyze dynamic distribution of population and capital stock both in a forward-looking way. So in the paper, we go through many types of analysis for the model, show how the model can be extended to many other settings, and apply the model through a particular application. We hope the model can be used in many other applications as well. So I'm going to stop here, but I've prepared other material in going into more detail of how the model fits into the literature. I can elaborate on the spectral properties and how we exploit that to understand the convergence property or the actual empirical application of the data. I'm going to stop here. Thank you.
Thank you very much, Ernest. That was great. Does anyone have any questions at this point? Not you are. Oh, Jonas.
Yeah, just one question, which is kind of related to understanding better, but also thinking of extensions that you were just talking about. So one thing I was wondering, so you separate the kind of the landlord investment decision and the household migration decision. Is it possible to have households that invest in a global investment good, so not local, and then have this, I suppose what you would need like a closed form consumption savings decision? But I guess this you could have, right?
Right. So if the workers can invest in a global mutual fund, but not local, that would be tractable.
Okay.
What gets out of hand is because agents in this economy, they migrate. So they carry a history of locations. And the history is path dependent. So going from A to B to C is different from going from B to A to C. So that if you allow them to carry a history of local investment in capital, that dimensionality quickly blows up. Sure. What we can do is set up national mutual fund, like you said, or allow the landlords to invest in various locations. Because landlords are not mobile, that is still a tractable analysis. Thank you for the question.
Sure, thanks.
Richard?
I have a question.
Yes.
Can you solve the model around the steady state with spatial features and then get the speed of convergence under spatial assumptions?
That is actually precisely what we do in the sense that you can think of the model as the following. Each period, workers and landlords are solving a trade problem. Each period, each location trade with each other. At the end of the period, workers choose migration decisions and landlords choose how much to invest into next period. So there's a very rich geography of trade and migration, which are the spatial features. And that's inherently important components of the model. Now, we also allow for some forces of agglomeration, endogenous or exogenous agglomeration forces, and we have that extension in the paper as well. Thank you.
Right, thank you so much.
Richard.
To ask your question.
Hey, Ernest, on the slide you say you explain the decline in the rate of income convergence over time, and can you, I don't know if you said it quickly, what's the economics behind why that's happened in your model?
Okay, so I'm gonna go through that with a few pictures. This is the income convergence. So we separate this half a century into 3 periods. The initial about 2 decades or so data. If we plot the annual growth rate of income per capita in that period against the initial log income per capita, we see a negative slope. This is saying that states that start off having lower income per capita grow quicker. So that's income convergence in the initial period, okay? We plot it over time, we see a decline or absence of convergence in the last part of the data. That's what we mean by decline income convergence. What we do in the paper is we actually use the model to recover fundamental and feed the fundamental shocks. That's one exercise we can do. We can think about what are the fundamental shocks that's changing the economy, both in terms of transition and also shocks affect the steady state. The second exercise we did was we take the initial US economy in 1963, and we assume productivity, amenities, trade, and migration factors are all constant for the rest of the sample. And we just run the economy forward. So take the 1963 economy, assume productivity just doesn't change across space and time. And we let the economy converge to steady state and look at the dynamics. Turns out the economy behaves very similarly to that counterfactual economy. So it's as if all the shocks to fundamentals that happened in the last half a century didn't quite matter. A lot of the decline in population from Detroit and changing capital stock distribution across US states is already driven, encoded by the initial condition in 1960s. It's a result of several factors. Number one is adjustment is actually very slow. So if you think about the half-life of adjustment in using real world migration data, turns out the half-life takes decades. So the adjustment of US economy to fundamental shocks is just very slow. Largely it's due to slow migration in response to changes in economic fundamentals. Families don't move very much. Now, what this figure shows is at each point in time on the x-axis, I am showing you in red the correlation of the 10-year growth and the ex-ante income. So I'm essentially plotting the slope or the correlation level of the previous figure that I showed you for each point in time. Red is what's observed in the data, and the dashed line is what's observed in the predicted by the model if we use 1963 fundamental and just run the model forward, allow the model to converge. We see a similar decline in income convergence just because the economy is much closer to the steady state relative to the initial conditions.
Okay.
Thank you very much, Ernest. I think that's all we've got time for, but we'll be returning to the main room for the last presentation of the day.
Thank you very much.
Thanks.